Friends, right now we will be talking about the trends, the periodic trends in terms of the chemical properties which are known to us. The first trend that we will be going into right now will be the trend of the change of valency or the oxidation state, which is also called as the oxidation number of the elements in the periodic table. So here we will be having a situation wherein the valency or the oxidation state, it keeps on changing. Let us look at what happens as you go from left to right in any representative, in the case of representative or normal elements. Because in their case, the oxidation number or valency is predictable. If in case we go to D block or F block elements, the valencies, there are multiple variable oxidation states and variable valencies which are applicable for many of those elements, wherein it is very difficult to find a trend in them. So as of now, we will be trying to find some amount of trend in the representative or normal elements, wherein we will be now talking about the elements, like say for example from sodium to in the case of chlorine, wherein we will try to find out their valency and oxidation states. So let us start with writing down the at the sodium atom. So we know that after sodium we get magnesium, right? So after magnesium we have got aluminium, after that silicon, after that phosphorus, after that sulfur, and finally after that chlorine. Now let us write down the valency or oxidation state which will be applicable for all of them. In the case of sodium, we know very well that the oxidation state which is applicable in the case of sodium will be +1, and the valency will be equal to 1. Now, sir, what is the meaning of valency and what is the meaning of oxidation state? Guys, you should have known all these things of what is the meaning of valency and oxidation state up till now. However, it's not a problem. I'll explain to you. Very, very simple. Valency is basically the number of electrons which are given out, or which are accepted, or which are shared to form the electronic configuration of its nearest noble gas. The only thing is that valency doesn't tell you whether electron is lost or electron is gained during this process. So therefore, valency never gives you a plus or minus sign. However, if in case you want to know whether electron has actually been lost or electron has actually been gained in this process, in that case you need to pay attention to another term which is called as oxidation state or oxidation number. If in case an oxidation state or oxidation number has a positive sign, then we know that electron has been lost. If in case an oxidation state is say for example is minus, in that case we can say that the negative oxidation state corresponds to a situation wherein electrons have been gained. Obviously, because negatively charged electrons, when you gain them, you get a negative charge on yourself. If negatively charged electron you lose, hence you have given off negative charge from you, hence you yourself get a positive charge. So that is the fundamental point behind it. So here we will be quickly writing down the valency as well as the oxidation state. The only difference between valency and oxidation state, very simply stated, is that oxidation state simply gives a plus or minus sign before the number which is given by valency. So here we will be, in the case of sodium, if in case we explain it properly, in the case of sodium we know that one electron is lost to form the electronic configuration of its nearest noble gas, which is neon, right? So here in the case of sodium, neon is its nearest noble gas. So to form the electronic configuration of its nearest noble gas, neon, that is 2,10, sodium loses its 1 electron, and because it loses its 1 electron, its valency is equal to 1. However, because it has lost, hence it will get an oxidation state value of +1. So let's write it down. So here will be the oxidation state value. This will be the value of the valency which will be applicable. And finally, this will be the noble gas in which this particular element will be getting converted. So in the case of magnesium, it has an electronic configuration of 282, hence it gives off 2 electrons. Because it loses 2 electrons, therefore it gets a +2 oxidation state sign. Its valency therefore is equal to 2 because it has lost 2 electrons to form the electronic configuration of its nearest noble gas, which is neon, who has an electronic configuration of 2,10. In the case of aluminium, similarly 283 electronic configuration, it loses 3 electrons and hence it will form the electronic configuration of its nearest noble gas, which is neon. In the case of silicon, it has electronic configuration 284, hence it has two options. either it can give away its 4 electrons or it can accept 4 electrons. In both the situations, its value of valency becomes equal to 4, and it either will form the inert noble gas configuration of neon or it will form the inert noble gas configuration of argon. If in case it loses 4 electron, it will form neon. If in case it accepts 4 electron, then it will form the inert gas configuration of argon. Let us see what happens in the case of phosphorus. In the case of phosphorus, we will be having a situation wherein the phosphorus having electronic configuration of 285. So either it will give away its 5 electron when it will get an oxidation state of +5, or alternatively it will accept 3 electrons. So its tendency of accepting 3 electrons will be obviously more in the case of phosphorus. So therefore, in the case of phosphorus, we have its valency equal to either 5 or equal to 3. However, in the case of phosphorus, it will form the inert noble gas configuration of argon. Next, we will be going into sulfur. Sulfur electronic configuration 286. Hence, either it will accept, either it will be giving out 6 electrons or it will be accepting 2 electrons. Therefore, if in case it gives out 6 electrons, it will form an oxidation state of +6, or if in case it accepts 2 electrons, in that case, it will have an oxidation state of -2. In this situation, it will try to get the electronic configuration of its nearest noble gas, which is argon. Finally, in the case of chlorine, we have an electronic configuration of 287, as you already know. There we have an option of either giving away 7 electrons or accepting 1 electron. If it gives away 7 electron, in that case it will get an oxidation state of +7. If in case it accepts 1 electron, in that case it will be getting an oxidation state of -1. So most of the time chlorine will have an oxidation state of -1. Most of the time sulfur will have an oxidation state of -2. Therefore, in the case of chlorine, it will try to attain the inert noble gas configuration of its nearest noble gas, which is argon. So here I have written down all the oxidation states. In the first horizontal component, I have written down all the valencies, and finally here I have written down the noble gas, which will be the nearest noble gas, in which these elements will prefer to get its electronic configuration similar to. So my dear friends, I hope so that you have understood the valency or oxidation states of elements when we go from left to right in the periodic table, specifically here in terms of representative elements. But if in case we choose to go from up to down in the periodic table, then it is to find out the valency or oxidation state will be very comic, because we know that all the elements which will be lying below sodium will all of them have the same oxidation state of +1. It will have the same valency of 1. So all the elements which is lying below magnesium will have the same oxidation state and valency. In a similar way, the same thing will take place for all these elements in a group. In a group, all these elements will be having the same valencies and the oxidation state which any one of these elements has. So I hope so, my dear friends, that you have understood the entire part of the valency and oxidation state, and you have also understood the meaning for it.